Hello, Algebra Scholars. This is section 5.4, factoring difference of squares, that we are going to call a DOS. Probably the easiest type of factoring that we're actually going to cover, and our last type of factoring we're going to cover. To be a DOS, there have to be only two terms. It's the only type of factoring with two terms. One term has to be positive, one term has to be negative. You'll always put the positive term first, and both terms have to be perfect squares. So every DOS will look like this: a squared minus b squared. And if you can make it look like that, it will always factor into a plus b times a minus b. So here's a first example. If I asked you to factor 4x squared minus 49, we could show that the first term is a perfect square. We're squaring 2x. We can show that the last term is a perfect square. We're squaring 7. And that proves it's a DOS. And therefore it will factor into 2x plus 7 times 2x minus 7. In the second example, we see two terms again. First one's positive, second one's negative. The first term is a perfect square. We're squaring 9. Second term is also a perfect square. We're squaring x cubed. If it helps you, feel free to identify what's inside the first parentheses as a and what's inside the second parentheses as b, and the problem will always factor into a minus b times a plus b. The order of these two binomials doesn't matter. In this final example, don't forget that you always have to check for a greatest common factor, and there is one here. There's a 2. And if we factor it out, we're left with x squared minus 9. Let's ignore the 2, or we'll write it down here to remind ourselves about it. Then we see that the first term is a perfect square. We're squaring x. The last term is a perfect square. We're squaring 3. So this DOS factors into x plus 3 times x minus 3, and then don't forget the 2, which we took out as a GCF to start the problem. In this very last example, something unique happens that doesn't happen too often. Once again, we see two terms. One's positive, one's negative. The first term is a perfect square. We're squaring x squared. And in the last term, we're squaring 9. So a is x squared, and b is 9. So we factor into x squared plus 9, x squared minus 9. But take a look here. Before we box this answer, this binomial here is another difference of squares. This one's a sum of squares, and a sum of squares, which we'll call an SOS, a sum of squares doesn't factor. You can't factor x squared plus 9, but we can continue factoring x squared minus 9. So we will bring down the x squared plus 9 because we can't do anything with it, and then we'll show that this second binomial is a DOS. We're squaring x, and we're squaring 3, and so this one factors into x plus 3 times x minus 3. And that is the final answer to this problem, oftentimes referred to as a double DOS. It's a DOS within a DOS. And that's it for factoring, everyone.